Hello, everyone. How are we doing today? Oh, I'm doing just fine. Just getting that ready to go, I hope. Miss Jackson, you doing okay?
Yes, I'm doing okay. You?
I'm just fine. You know
That's
you
good.
gotta stop before class starts, right?
Huh?
You gotta stop before class starts, right? You know that.
What you mean?
I just gotta let you know the game's regulations to be moving. I do
Okay.
have. All right, kind peoples, how are we doing today? I'm just waiting for everyone to arrive. And while I am doing that, I can remind everyone to please turn on their cameras. Um, while I'm reminding you guys to turn on your cameras. I need to share my screen. All right, so first things first, right here. I posted on the unlock practice, and so that should give everybody the opportunity to go ahead and try out the unlock system to see if there are any bugs. You will need the unlock system to work if you are when you're taking tests. Again, so if you go into unlock right now, I guess if I switch to the student view. Where is my student view? I need it. You're a student. So right here, you see unlock, you click on the unlock right now. You should see the testing right here, launch the third party, and you should be able to go through the whole process. So what, like I said, I go do some research. There is a password for these kind of things, but you don't need to know the password. I have told unlock the password, and what happens is when you go through that process, at the very end, when you're about to take the assignment, they ask you to go to the assignment. So the last step is you go to the assignment that you need to open, and when you go to that assignment, where do you go? Yeah, unlock test right here. When you go to this assignment right here, you open up this page. Right? Unlock will put the password in for you and then allow the assignment to start. All right. So that's that.
Wait,
Anything
so we just
else?
click
Go ahead.
we just click launch and it's okay. There's no password.
Yeah, yeah. Once you click launch, it'll ask you to basically identify yourself. So you have to show your room, show your ID, all that kind of stuff. And then after that, right here, it will then go ahead and ask you to select the assignment. That's
Okay,
it.
thank you.
And then you go into modules and then you find the assignment. Now, when you can see the password on that page, when you see you get, where did it go? When you see you get to this stage right here and you see there's a password right here, you go back to the unlock window and you click the button and it'll put the password in for you. All right. You had to do a whole bunch of research to find that out. Anyways. Anyways. Okay, and then I posted a small announcement right here about anyone who's interested in the literary magazine. You can go ahead and you can look that over right there. All right. Any more announcements? Um, I think that's all my announcements. And so I can get started. So let me stop sharing here so I can start sharing here. You guys can see my screen?
Yes.
All right. Okay, everything seems to be working. All right. So basically, right now, what we're going to be doing is we're just going to be continuing with some of the examples that we want to work on. Because remember, right now, we're working on solving equations. And we started looking at some more exotic, different, or weird-looking equations that examples, just help us out. All right. So m plus 2 squared equals 14. No, actually, let's not use 14. Let's use 48 right here. And I am trying to solve this question right here. This question right here is set up for us to use the square root property. If you recall, the square root property is if I have x squared equals 9, if I take the square root on both sides, I get x equals plus or minus 3. The main idea here being that when you take a square root on an equation, you have to include both answers. And so for this problem right here, all I have to do is to take the square root on both sides. And in so doing, these two will cancel. And that leaves me with m plus 2 equals, now 48 is special. If it was 49, then we'd have been business. The square root of 49 is 7. But 48 is special. It is not a perfect square. And so I am just going to have to go plus or minus radical 48. At the end, we're going to simplify the radical. But we'll do that at the end. And so now right here, this problem just has one more step. since I am solving for m, I'm going to subtract 2 from both sides. And so that leaves us with m is equals to -2 plus or minus radical 48, which means m equals -2 plus radical 48, and m equals 2 minus radical 48. Any questions before I switch over to simplifying the radical? Again, please turn your cameras on. Please and thank you. All right, so this question is correct, but it is not completely simplified. And whenever we have a radical, we have to go ahead and do that process right here. Now, there are two major ways to simplify a radical. I will show you one of them. If you want to see the other one, you can come to my office hours after class, and then we can talk about it. So I want to simplify radical 48. Well, what I need are our perfect squares. Let me remind you, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, and so forth, so on. And 14 squared is 196, 15 squared is 225. But these right here are perfect are squares. So the process, one of the processes right here of simplifying a radical is you have to find the largest perfect square that divides into 48. Of course, you can use a calculator to help you out, but hopefully you will see that that number is 16. 16 multiplied by 3 is 48. 16 multiplied by 3 is 48. And so now that I have that key fact, the square, I split the 48 up. 48 is 16 multiplied by 3. Have I lost anybody? And so my last step then is to simply take the square root right here. The square root of 16 is 4. Radical 3, you cannot simplify. And so this breaks down to 4 radical 3. Can you see why I am looking for a perfect square as one of the numbers that divide into 48? Can you see why I'm not just using any number to divide into 40? I'm looking for perfect squares. Because when I split it up, the perfect square is going to simplify. Yes? Make sense? And so with that right here, I get my simplified form. And so I can rewrite my answers. M equals -2 plus 4 radical 3. And M equals -2 minus 4 radical 3. Questions there? Comments? Queries? Concerns? All right. Let's try another one. So this right here is example number 2. Let's say I have r plus 7. That's not a 7. R plus 7 multiplied by r plus 5 equals 3 right here. And I am trying to solve this problem right here. Whew. This looks kind of simple, right? You just go r plus 7 equals 3, and then r plus 5 equals 3, and then you're in business, right? No, wrong. Remember, this process right here of splitting them up, we use the ZPP, the zero product property. For the zero product property to work, this number must be 0. Since it's a 3, i.e. not a 0, I have some work to do. And so what I have to first do is expand the equation. R times R is R squared. R times 5 is 5R. 7 times r is 7r. 7 times 5 is 35. And all of this right here equals 3. And so that's going to be r squared plus 12r plus 35 equals 3. And then I'm going to move the 3 over. So I'm going to subtract 3 because to use the zero product property, it must equal 0. 12r plus 32 equals 0. So let me pause right here. So literally, we have done nothing to solve the equation. We have just rearranged the equation to put it into a position where we can now solve. Questions there? So now that we have done this, I can then go ahead and solve. So we're using the AC method. So let's identify my values. A equals 1. A is the number in front of r squared. B equals 12. B is the number in front of r. And C equals 32. C is the number by itself, the term without an X. Put your lovely diamond. Up here is AC. And so we multiply A and C. 1 times 32 is 32. And then down here we have the value of B. B is just 12. And I need two numbers. When I multiply them, I get 12. I get 32. And when I add them, I get 12. And anybody tell me what those two numbers are? Anybody? Mason says it is 4 and 8, and those numbers are correct.
You want us to put this in the chat or the thing you assigned already?
I'll tell you when. I'm about to. Not just yet. I'll tell you when. 4 multiplied by 8 is 32, and then 4 plus 8 is 12. All right? And now at this point right here, we can use a shortcut. Because A is 1, I can use the shortcut. S-H-O-R-T. I can just simply go x plus 4, and then x plus 8 equals 0. Remember, if A was not 1, I would have to go through the whole process of regrouping and factoring. But because A is 1, 4 and 8 are automatically the two numbers that I need. And so therefore, by using of the zero product property, x plus 4 equals 0, and then x plus 8 equals 0. Those are both one-step problems. X equals -4, and then x equals -8. Questions there? Questions there? All right, cool. Waiting for you all to finish up writing. If I go to my third example, my example number 3. All right, we ready to move to example 3? All right, good. I'll leave the rest of it right here. So the last example right here is one that's very specific. In this one right here, you have 4 terms, which is one that we have not seen before. 5 multiplied by a to the 3rd power plus 8 multiplied by a squared minus 10a minus 16 equals 0. And I am trying to figure out what are the answers to this problem right here. The key to solving this problem right here is that you have to notice that there are 4 terms. And we can solve them by grouping the terms. If you look carefully right here, I can look at this pair as one set of numbers, and then this right here as a second pair of values. So what can I factor out from here? So you factor this pair only. I can factor out not a 5, but I can factor out an a squared, right? Because they both have the a's in them, and the lowest power of a is 2. So at most, we can factor out just an a squared. So I'll do that. So I'm going to have a squared, open parentheses. When I factor out an a squared, this and this will cancel out. And so that will leave me with 5a plus 8. Again, you should always double check when you're factoring. And so if I, for listing out, a squared times this is 5a cubed. A squared times 8 is 8a squared. And so we are in business. Again, the second pair, we do the same thing right here. What do these two things have in common? The 10 and the 16. In this case right here, the number they have in common is -2. And so I'm going to factor out a -2. And so that's going to leave me with 5a plus 8. Okay, factor out. Now, it's very important right here because you could have factored it out too, but if I factor out 2, these two things are not the same. Your goal is to get these to be the same. Because if they're the same, I can factor it out. Just like we did when we were factoring the quadratics. So 5a plus 8 is the same, so it gets factored out. And so that's going to be 5a plus 8. And then when I factor it out, it gets removed. What's left is going to be a squared minus 2. Again, equaling 0. Questions there? And so with this right here, I can then set each of these equal to 0. 5a plus 8 equals 0. And then a squared minus 2 equals 0. This is a 2-step problem. Subtract 8. 5a equals -8 divided by 5. So a is equals to the fraction -8/5. And then on the other side, a squared minus 2 equals 0. I'm going to add 2 to both sides. And so that's going to be a squared equals 2. Again, this is a square root property function. And so I take the square root right here. And so a is going to equal plus or minus radical 2. And so therefore a equals radical 2, a equals negative radical 2. We got 3 answers. Now that was a lot. Any questions there? Any questions there?
No.
All right. Go ahead and try these two for me. This right here is our first discussion. Slash, again, remember, we have to do this for attendance, so you need to give me some kind of answer. And I have two questions for you. The first one right here is x minus 9 squared equals 32. And then give your answer in radical form, reduced radical form. And number two is going to be 5 m cubed plus 4m squared plus 15m plus 12 equals 0. All right, go ahead and try these two for me, please. If at any point you're running into a problem, let me know. But I want everyone to post
Do
an
you
answer.
want us to? Oh,
Yes, ma'am, I do. So if you go into Canvas and then you go to module 2, I think I put it in. Let me double check where I put it. Oh, August 27th. Yeah, so it's at the end of module 2. It's attendance questions right there. Let me stop sharing for 1 second so I can show you. I'll put it back in 1 second. Yeah, so if you go into modules, module 2 graphing distance midpoints is right here, August 27th. All right, let me go back. Feel free to raise your hand or make a post to the notes to the chat. It can be a private message if you want to. So in Canvas, to type a symbol, let me see if I can show you how to do that. So if you go in here, into right here, so I can reply right here. So if you want to type mathematics right here, see these little 3 dots over here? You click on those right here, and then you look for this right here symbol. That's the math palette. So you click on that right here. And so for example, if I want to write, say, negative square root of 5, you type negative, hit square root button, and then you hit the 5, and then it'll put in the negative square root of 5. All right, so yeah, you have hit these little triple dots for extra, for more, I guess, and then look for this symbol right here. That's your math palette. All right.
wait, do it again.
Yeah, hit reply to bring up the radio. These 3 dots right here for more. You click them and you look for this symbol right here. That's your math palette. Click on that. And that will bring up just about any kind of math that you need. I think someone's asking about radicals. So you have your radical right here. You can do fractions, you can do powers. You can do just about everything that you need. At least anything that I'll need from you. All right. That's a good point. That's a good point. I only want the real solutions for now. We'll get the imaginary solutions later. But you don't have to go back and change it. That's fine. Now, again, you do need to give an answer. Doesn't have to be right, but you do need to give an answer. You give your answers help me figure out how well overall the class is doing. Yeah, I'll give you another 2 more minutes. Finish. All right. Go ahead and post what you have. Let's move forward. All right, so let's look at the first question right here. Anybody wants to help me answer the first one? Anybody want to help me answer the first one? Going once, going twice. Please, for cherry on top.
You
So did you
square,
say
Go ahead.
you square root it, and then you get x minus 9 equals square root of 32.
Give me 1 second. So you take the square root on both sides. And so x minus 9 equals plus or minus radical 32, right? If you don't have that plus or minus, you lose one of the answers. Okay, what's next?
You add the 9 to the other side, and then you get 9 plus or minus 32.
And then simplify the radical.
You get 9 plus or minus 2, and then square root 8.
Well, that's almost right. That is not fully simplified. That is correct, but it's not fully simplified. You have to use 16 and 2, not 4 and 8. That's why you have to use the largest perfect square. And so then you take the square root, and square root is going to be 4 radical 2. So it's going to be 9 plus or minus 4 radical 2. 9 plus 4 radical 2, 9 minus 4 radical 2. Thank you. Any questions there on this first one? Anybody want to help me with the second one? Anybody want to help in the second one? All right. This one right here, there are 4 terms. Oh, someone want to help me? Go ahead. Go ahead.
hello?
Yes, go ahead.
Okay, so first I put parentheses around the 5m cubed plus 4m squared,
Mhm,
and then the 15m and the 12.
mhm,
And then I took m squared out of the first set,
mhm,
and I took 3 out of the second set.
mhm,
And then I equaled both equations to oh wait. Oh yeah, I equaled both equations to 0.
Well,
Like both.
before you do that, you have to get the 2
Oh,
equations, right?
yeah, then I put the m squared and the 3 together, and then the 5m and the 4, and then I equaled both of them separately to 0.
Mhm.
And I got m is equal to plus or minus the square root of 3. Oh, no,
Hold on.
wait, not for that one. That one
Yeah.
I got m is equal to negative 4 over 5.
Negative 4 divided by 5, divide by 5. So m is equal to negative 4 over 5.
And then for the second one, I square rooted both sides. Or I put the 3, sorry, I'm skipping ahead, yeah. And then square rooted both sides.
Move the negative 3 over. And then you square root both sides. And so m.
Is equal to plus or minus the square root of 3.
So now we have to be careful here. You cannot take the square root of a negative. You cannot take the square root of a negative number. And because you cannot take the square root of a negative number, this thing stopped sharing. Oh, I got kicked out of the meeting. Hold on. Because you cannot take the square root of a negative number, because you cannot take the square root of a negative number, the answer we say is no real solution. Okay, I'm almost back. right? Now, later on, we will deal with taking the skirts of negative numbers. The answers are complex numbers, but we'll get to that at another time. Questions there before we move on? All right, so the last piece right here before we finish off this section is we have to deal with manipulating equations or solving for a value. So let's look at a few examples of those. Let's say I have, for example, y is equals to 7, 8 minus x right here, and they want me to solve for y. Solve for y, right? Well, whenever you see a fraction, the first thing you should do is multiply by the common denominator. Now, since on the left side it's y over 1, and on the right side is 8 minus x, the common denominator, the lowest common denominator is going to be 8 minus x. Generally speaking, the lowest common denominator, well, the common denominator is the product of all the denominators. And generally speaking, there are no common factors. Then your lowest common denominator is just going to be all the denominators multiplied together. Now, that sounds like way too much to say. Let's look at a few examples. So in this example right here, if I'm solving for x, the first thing I need to do is identify the variable that I am solving for and where exactly it is, because we're going to have to track it as we try to solve this problem right here. So let me rewrite, I need space. Y is equals to 7 over 8 minus x. And what we do is we multiply both sides by the denominator, because that is our lowest common denominator. 8 minus x, and over here, 8 minus x. What will happen is that on this side, the denominator will clear, and so that will leave us with y multiplied by x minus 8 equals 7. Again, I am tracking the x. And so I need to get it by itself. So I'm going to distribute the y. So xy minus 8y equals 7. And I'm almost there. Going to add 8y to both sides. So xy equals 8y plus 7. And then I'm going to divide by y. And that will leave me with the x by itself. Any questions there? Let's try another one. Let's say I have 8 over m is equals to 5 over s plus 3 over b. And I am trying to solve for s. Solve for s. Again, s, that's the s right here. S is right here. It's in the denominator. And so I'm going to need to clear my denominators. If you look very carefully at the denominators, notice nothing repeats. M, S, and B are all unique. And so therefore, there are no common factors. And so therefore, your lowest common denominator is going to be the product of the three, M, S, B. And so we have to multiply every term by MSB to clear the denominators. So, let me get some more space. 8 over m is equals to 5 over s plus 3 over b. I am going to multiply each term by MSB. MSB, MSB, and MSB. Have I lost anyone? Questions? Now we have to use
No.
our rules for fractions. Thank you. And that is, we cancel out high and low terms. We cancel out the multiply and the dividers. So the m will cancel with the m right here. The s will cancel with the s right here. And the b will cancel with the b right here. And so that will leave us with 8 SB equals 5 MB plus 3 MS. And this takes us to one of those tricky situations. You just told me, kind sir, please solve for x, solve for s. But there are two s's in the equation now. There is one s right here. And then there is one s right here. And then there's another s right here. Well, how am I supposed to solve for s? I don't know. Well, what you have to do is gather all the s's together on one side and then factor it out. You have to gather the x's. I keep saying x's, s's in this example. So I am going to subtract 3ms on both sides. And that will leave us with 8SB minus 3MS equals 5MB. And now on my left side, I can factor out S because S is what they have in common. So you factor out S, that leaves us with 8B minus 3M. And that solved the S problem because I had two S's. But now that I have factored, I only have one. A little magical tool we have. I divide by 8b minus 3m. I divide by 8b minus 3m. And that is our answer. Whenever you come across a situation where you have more than one of the variable, that's what you got to do. You got to gather them all together, bring them to one side, and factor it out. Questions there? All right, so I'm about to switch gears. I'm moving into module 2. And that is our coordinate system. So let me go ahead and just start a new page. This one in particular, I'm going to need the grids. So I'll pull up a grid right here. And let me not use black since the background is black. Let's work with blue. All right. And so what we are talking about right here is plotting points. If I had a single number line that looks like this, at the center of my number line, 0, 1, 2, 3, -1, -2. If I asked you to identify x equaling 3, all you'd have to do is simply put a dot or put a point at the value 3. Right? This right here represents x equals 3. This right here is a one-dimensional system, and we just have one variable. We can either move left or right. Your Cartesian coordinate system or your XY plane takes this to the next level. Your XY plane, PLA, is a situation where we have two axes, one going up and down, and one going, come on, rotate. and one going left and right. Like so. The one going left and right is called the x-axis. It resembles the number line I just had a while ago going left and right. And then what they did was they took a second axis and they put it perpendicular at a right angle. Call it the y-axis. When you do this right here, this splits space or your xy plane into what are called quadrants. This right here is quadrant 1. This right here is quadrant 2. Now, for some reason, they love using the Greek letters over here. I don't know why. This is quadrant 3 and quadrant 4. Now, if you notice very carefully, they're named in a counterclockwise manner. There's actually a specific reason why they're naming them in a counterclockwise manner, but you'd have to take a class called trigonometry to go back over and understand why they decided that it's more mathematical to go in that circle backwards. All right. Questions there? So your XY plane right here is made up of two number lines. Let me just go ahead and put some numbers on my number line. So 1, 2, 3, -1, -2, -3, 1, 2, -1, -2 right here. And so again, it's just two number lines going up and down. To describe a point in space, because this is now a two-dimensional space, we use what is called an ordered pair. An ordered pair is simply written as x comma y. The first number always refers to the value of the x axis, and the second number always refers to the value of the y axis. Generally speaking, when we write an ordered pair, we give it a name. In this case, I'll give it the name A. The first number is called the x coordinate. And the second number is called the y coordinate. To plot a point in two-dimensional space, we have to find the point in space where both things are true, where x is 1 and the y value is 2. So what we do is we locate 1 on the x-axis. Where is 1 on my x-axis? 1 on the x-axis is right here. And we locate 2, excuse me, in the y-axis. What color shall I use? Let's go with purple. I like purple. And we locate 2 on the y-axis. And we find the point in space. We find the point in space where both numbers are. So if you look very carefully, if I look down at the x-axis, I'm looking at 1. And if I look across to the y-axis, I'm looking at 2. So you find that point in space where both things are happening at the same time. This is a unique perspective, i.e., if I say find the point 1, 2, there's only one point in space that covers both values. Questions there? The point 1, 2 will be in the first quadrant. So I can just write here Q1 to represent the first quadrant. If you look very carefully at the x and y coordinates, you can figure out what quadrant a point is. Consider the point B with -1, -2. 2. I wanted to plot the point -1, -2, I identify -1 on the x-axis. Again, it's very important. If I'm identifying the wrong axis, I will get lost. So I identify -1 on the x-axis. I identify -2 on the y-axis. Uh-oh, I forgot to remember my, there we go. I identified -2 on the y-axis, and then I find the point where if I look towards the x-axis, I will see -1, and if I look towards the y-axis, I will see -2. This right here is point B. Questions there? Can anybody tell me what quadrant point B is in? Quickly now. What point? Where is B? What quadrant is B in?
3.
It is in the third quadrant. That is correct. It's in quadrant 3. So B is in quadrant 3. Any questions there? So the basic rule is x comma y. If they're both positive, you're in quadrant 1. If they're both negative, you're in quadrant 3. If x is negative, you are in quadrant 2. If y is negative, you're in quadrant 4. Okay, you just have to look at the values in front of x and y to figure out what quadrant we're in. Any questions there? That's strange. Oh, all right. Okay. All right. So that takes us into our next right here. And this right here is graphing lines. The equation y, it's not the equation I want. The equation 3x minus y equals 2 right here. This right here is a linear equation. It is also said to be an equation of the first degree or the first order. Oh. Again, degree and order here means the same thing. Can anybody tell me why? First, F-I-R-S-T. Can anybody tell me why this is called an equation of the first degree?
Say it again.
Can anybody tell me why this is called an equation of the first degree? Why is the first degree equation? It is a first degree equation because all the variables, the highest power is 1. Okay? Generally speaking, linear equations can be written one of 3 ways. Ax plus by equally c. We call this general form. It can be written in the famous y equals mx plus B, and this is your point slope intercept form. And it can be written in y minus y1 is equals to m times x minus x1, and this is called point slope form. All three of these forms are equivalent. They're all first degree equations. If you look very carefully at all of the variables, x and y are all raised to the first power. Questions there?
No.
All right. So how do I graph the line 3x minus y equals 2? How do I graph this line? Well, it turns out that this format right here, general form, is not necessarily the best for graphing lines. And so normally what you would do is you would first convert to slope intercept form. And to do that, we have to do what we were just doing a while ago, is that we have to manipulate the equation. We have to solve for x. We have to solve for y, my bad. And so I'm going to take the 3x over minus 3x. And so negative y equals negative 3x plus 2. And then I'm going to divide by negative 1. Divide by negative 1, divide by negative 1, divide by negative 1. And that will leave me y is equals to 3x minus 2. This right here is equivalent to the original equation. But when the equation is written in this format, it gives us more information, and it's a little bit easier for us to understand. Questions there? Questions there? Okay. So now from this point right here, there are several options to graphing these things right here. Let's take a look at two of them. The first way to graph is using what's called a table of values. Your table of values are made up of two columns, x, comma, y. Your x values are called your independent variables. And of course, it refers to your x-axis. And your y represents your dependent variable. It is dependent because it depends on your choice of x. See what I did there? See what I did there? No. No. And so, again, your y's represent your y coordinates, your y-axis, your y coordinates. I should say coordinates. Again, just giving you guys information. Because your x values are independent, you can choose any number that you want for x. In this case right here, I'm going to choose nice, neat, easy numbers to work with. And then now that I have the x values, the values of y are dependent on my choice of x. And so what I have to do is I have to work out what each of the y values are. So for example, let's say x equals -2. That's my first point. Y is going to be 3 multiplied by -2 minus 2. That's going to be -6 minus 2. that's going to be -8. And so my first point right here is going to be -8. All right, so for our second discussion question, I want you to complete the rest of the table. I want you to find the 4 remaining y values and post them to the discussion. I'll give you about 2 minutes for this. This hopefully won't take us too long.
You want us supposed to answer in this chat here or the other thing?
In the discussion, it's remember this. The discussion is how I take attendance. So whenever I say it's a discussion question, what I mean is not the chat. I mean to put it on Canvas, so I have save the record of your answers. And of course, to be here, you have to participate. You can't just show up, and then go to sleep. You actually have to be here. So you have to do something. Everyone is required to post.
You're muted.
My bad. All right, so before we move on, those numbers that we just found right here, -2, -8, -1, -5, 0, -2 right here, these are called solutions to the equation. You could use either y equals 3x minus 2 or 3x minus y equals 2. Doesn't matter, because remember, they're equivalent. It doesn't matter which one you use right here, but the key thing right here is that they're solutions. And what we mean by solutions is that if you plug these two numbers into the equation, the equal sign will be true. So if I take the ordered pair -1, -5, and I plug it into the equation, so that's going to be 3 multiplied by -1 minus -5. This expression should work out to be something that is true. 3 times -1 is -3. A negative times a -5 is a +5. And -3 plus 5 is indeed 2. A solution is a set of numbers that when I plug them in, the equal sign holds. So for example, 0, -5 is not a solution. If I plug in x equals 0, I plug in y equals -5, the statement I get, the equal sign is not going to hold. 3 multiplied by, let me plug it in right here. 3 multiplied by 0 minus -5. 3 times 0 is 0 plus 5. This right here is not true. Your solutions are ordered pairs that when I plug them in, the equal sign holds. Questions there? And so we just found a whole bunch of them. I just chose values for x, I plugged them in, I computed the value of y, that gives us a solution to the equation. I could have done it in reverse. I could have picked the value for y, plug it in, solve for x. Again, x comma y, that pair will be a solution. The way you check to see if a pair is or is not a solution, you plug it in and you see if the results may hold for the equal sign. Questions there? I can see I am running out of time. I was going to graph the ordered pair. I guess maybe I have enough time to graph the ordered pairs really quickly. If you plot the points, -1, -2, 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, x and y axes, x axis, y axis. If you plot the points in the table, -2, -8. Let's go with purple. Why is my iPad so slow? Reset it. Let's just go with the black then. Always, huh? So -2, -8, that's -8 down here. That's this point right here. -8, -6, -5, -5, -1, -5 is right here. -1, no, 0, -2 is right here. 1, 1 is right here. And 2, 4 is right here. If I plot all those points and I connect them, this would give me the line that represents y equals 3x minus 2, or if you prefer 3x minus y equals 2. Again, because they're the same equation. So you plot the points, connect them with a straight line, and that gives us right here the graph of the line. by using a table of values. We will end here. Any questions? Again, if you have not, please post something to the discussion board. That is how we keep track of attendance. Any questions?
I had a quick question about our test we have earlier today. I mean, later tonight, it's due.
Oh, you mean
There's
the
a password on it.
yes, ma'am.
I
All right,
just was wondering what the password was.
There is no. Let me go over that one more time. There is no password. Let me go over that one more time. So I share my screen. So what happens is that I actually give the password to Honor. So you never actually see the password. What happens is either you go into Unlock and then you look for the assignment right here, where it is, see this one, 7 people have already completed it. You don't need the password. Well, let me switch to student view. It's easier if I switch over to student view. So if you go into Unlock, and then you will see the assignment right here, and you see launch. You launch the assignment, and then Unlock will take you through this whole process. It will show you, make you show your ID. It'll make you show the room. It'll basically log you in. Once it's done that process, at the very end, it'll ask you to locate the assignment. So you will go into the assignment, and then once you go into the assignment, you come down right here to the assignment and you click on the assignment. And then once you get to this page, what you do is you go back to, because the Unlock has another window that's open. You go back to that and then click on enter password. And then the Unlock will enter the password in for you and start the assignment. Okay?
Thank you.
Okay, so there is no
Thank
password
you.
that is for you. I think I have, somebody gave me, where is it? It's Unlock right here. I think, there you go. Please read before taking Unlock. I think right here, seeing this video right here. If you go into this video right here.
You know what's really fun? Like your website only.
If you go into this video right
And
here,
once your
it
page
kind of walk you
ID
through the process.
capture as much, make sure the
Show
desk,
the room. I'm
you'll
trying to
notice
get
it's
to it
launch
really quick.
exam.
See right here, launch exam. So you go to the exam.
So page,
Right. So you see right here.
Insert it, right? So now let's go back to the camera view.
Go back to click insert
And
password.
right there, you'll notice insert password button. It's pretty clear.
Click on it. It'll put the password in for you.
And
then it will start.
magic happened. You didn't even have to know the password. Please and thank you.
And then that's how it goes. And then it'll start an assignment for you. All right. All right. Any more questions? Remember, I have office hours later on in about 13 minutes now. I guess I should show you that as well. The how do I go back? If you go, I created a new module. It's at the top, make it easy to find, Professor Contact. If you click on here, you should see the office hours Zoom link right here. All right, you guys have a nice day.
Bye. Thank you.
Thank you.
Messages. Ms. Dominguez, yes. Any questions?